Hey there, I hope you're doing well today. In this video, I'm going to be covering slope-intercept form for linear equations. While you can find the timestamps here, they're also linked in the description. Linear equations typically represent situations where we have a constant rate of change, and when put on a graph, we'll see that it always creates a straight line. While there are three main forms of linear equations, we're going to be focusing on slope-intercept form in this video. Here's the equation right here. Starting off with the more familiar variables, let's look at x and y here. This x and y are always paired together to give us the location of a point on the line. Looking at the graph here, we can see that 1, 1 is going to be a point on the line. Also, looking over here, we see that we have 2, 4 as another point on the line. Similarly, down below, we also have 0, -2 as a third point on this line. There are infinitely many points on every single line. We use x and y to represent all these values since they can be different at any point on the line. And just reminding you from pre-algebra that x always represents an independent variable. You can think of it as an input value and is along the x-axis. On the other hand, this y here represents the dependent variable and is also known as the output. This b represents the y-intercept. The value of b tells us where the graph crosses the y-axis. Keep in mind when the graph crosses the y-axis, x is always 0. And that leaves us with m. M represents the slope of our line. You can think of it as a rate of change or rise over run. It also might be helpful to think of slope as a ratio or rate of vertical change to horizontal change. Vertical meaning rising or falling, and running meaning left and right horizontal change. This location on the graph here is 0, -2. Since this is where the graph crosses the y-axis, we know our y-intercept is -2, and we can say b equals -2. To find the slope of a line, we have to first identify 2 points we can use. Since slope is a ratio of vertical to horizontal change, let's find the horizontal and vertical change to get from one point to the other. From the lower point to the higher point, we can see a rise or a vertical change of +3. For horizontal change, we see it moves to the right one, which is +1. Since slope just represents the ratio of vertical change to horizontal change, we can say m is equal to +3 over +1, which will simplify to just +3. And if you're wondering if you can go from the higher point to the lower point, you absolutely can. To get from the higher point to the lower point, your vertical change is going to be down 3, which is going to be a -3, and it's going to be to the left 1, which is going to be a -1. This ratio of vertical change to horizontal change is going to be -3 over -1, which still ends up simplifying to being +3. The constant rate of change or slope for this graph is going to be 3, or 3 over 1. You can see here that to get to each point, you always rise 3 and run 1. The vertical change is always 3, and the horizontal change is always 1. Don't worry about mixing it up and going backwards, because you can also go down 3 and to the left 1. You will still end up on this line. While the vertical change is -3 each time, the horizontal change is left 1 or -1. A -3 over -1 is equivalent to a +3 over a +1. In slope-intercept form, the equation of the line to the right would be y is equal to 3x minus 2. Whenever b is negative, you can just subtract it instead of adding a negative value. Here's what I'll cover in the rest of this video. First, I'm going to show you how to graph from slope-intercept form. Then we'll go over writing an equation given a slope and a y-intercept and graph it. Then we'll go over how to write an equation when you're given 2 points. Then we'll talk about what to do with vertical and horizontal lines. And we'll finish up with some application word problems. Let's get to work. In example 1, let's practice graphing equations when we're given slope-intercept form. Let's try an equation where we have y is equal to -2x plus 4. The plus 4 represents our y-intercept, or b. We know 0, 4 is going to be a point on the graph. The -2 represents the slope, so we can say m is equal to -2. Since slope is a ratio, we can write this as -2 to 1, or +2 to -1. Both of these are the same thing. To graph this equation, follow these 3 steps. First, you're always going to start by plotting the y-intercept, and in this case it's 0, 4. Then we're going to use the slope. If you're using the -2 over +1, that means you're going to go down 2 and to the right 1. You can do this repeatedly to get more points on the line. If you want to use the +2 over -1, you're just going to move up 2 and to the left 1. If you're doing this correctly, your points should create a straight line. This is going to be our graph of y is equal to -2x plus 4. Let's try another one here together. Let's say we have y is equal to 1/4 x minus 5. Our y-intercept is -5, so we can say b is equal to -5, and we know that 0, -5 is the point that we're going to start with. Our slope here is 1/4, so we actually already have our rise and run. If you don't want to use +1 over +4, keep in mind that you can also use -1 to -4. Let's begin by plotting our y-intercept of -5. It's going to go right down here, and that's done. Next, let's use the slope. Using the +1 over 4, we can go up 1 unit and to the right 4 units. Here's our 1 moving up and our 4 moving to the right, 1 moving up and 4 moving to the right. If you're using the -1 over -4, you can move down 1 and to the left 4. You can do this again, move down 1 and to the left 4. Now we've used the slope. And finally, let's draw the line. Here's the line right over here, and it represents the equation y is equal to 1/4 x minus 5. If you'd like me to make another video on more practice problems, please comment down below and let me know. In example 2, let's try a couple problems where we're not given an equation. Let's say we're given a slope of -3 and a y-intercept of 0, 7. Since we know the slope is -3, we can say m is equal to -3, and to write it as a ratio, we can write it as -3 over +1, or +3 over -1. From the y-intercept, we can say that b is equal to 7. Remember that slope-intercept form is y is equal to mx plus b. Substituting -3 in for m, and substituting in 7 in for b, we're going to get the slope-intercept form of y is equal to -3x plus 7. This will be our equation. To graph this, we would put 0, 7 on the y-axis, and use our slope to create more points that are down 3 and to the right 1. And you can also go up 3 to the left 1. Connecting these points, here's our graph of y is equal to -3x plus 7. In this example, we have a slope of 3 over 2 and a y-intercept of 0, -6. From this, we know m is equal to +3 over 2, or we can think of it as -3 over -2 if that's more useful for you. And the value of b is going to be -6. Let's substitute these values into our slope-intercept equation. 3 over 2 is going to be our m, and -6 is our b. Our equation here is going to be y is equal to 3 over 2x minus 6. Let's graph this now. First, we'll plot -6 on the y-axis. Then we're going to go up 3 units and move to the right 2 units since our slope is 3 over 2. Repeatedly doing this, we'll have these as our following points. Connecting these ordered pairs, here's our line. The equation of this line is going to be y is equal to 3/2 x minus 6. So if you're ever just given a slope and a y-intercept, this is how you would write the equation and how you would graph the line. In example 3, let's practice writing the equation if we're just given 2 points. Let's try one where we're given these 2 points of 0, -4 and -3, -1. Now if you had graph paper, you could plot these 2 points and see that we have a vertical change of -3 and a horizontal change of +3. From this, we could say the slope is going to be -3 over 3, or just equal to -1. But since we don't always have graph paper, we can use a formula to find the ratio of vertical change to horizontal change. First, we're going to label this first order pair as x1 and y1, and label the second order pair as x2 and y2. Slope, or m, is going to be equal to y2 minus y1, or the vertical change, divided by x2 minus x1, or the horizontal change. While this isn't talked about very often, if you did swap these two values and did y1 minus y2 and divided that by x1 minus x2, that's also going to be okay. As long as you're consistent with how you're doing it, you'll get good results. Substituting these values in, we're going to get -1 minus -4 over -3 minus 0. In the numerator, -1 minus -4 is just -1 plus 4, and that's a +3. And in the denominator, -3 minus 0 is just -3. This is going to simplify down to -1. Notice how these values match. Now that we found the slope, let's find the y-intercept. Be on the lookout to see if you're ever given a point where we have 0 in the x value. If that's the case, the b value is just going to be -4. Substituting our slope and our y-intercept into y equals mx plus b, we're going to get y is equal to -1x, or just -x, minus 4. This would be the equation of the line going through these 2 points. This is what the graph would look like. Here's 0, -4, or our y-intercept, and we can see a consistent pattern of down 1 to the right 1 pattern. Keep in mind that a down 3 to the right 3 pattern is the same thing as down 1 to the right 1 pattern. Now let's try a more challenging example where we're not given the y-intercept as a point. Start by labeling your points, and let's find the ratio of vertical change to horizontal change. The slope we should get is -3/5. Unlike the last example, neither of these points are the y-intercept. This creates a little bit extra work for us here. Looking at our equation of y equals mx+ b, we're going to get y is equal to -3/5 x plus b. Since we're looking for b, there must be some way to find out what x and y are. Remember that x and y represent any point along the line. While there are infinitely many choices we could use for x and y, we can use this -3, 4, or this 7, -2 since we were given them. Well, it's totally up to you. I'm going to choose to use -3, 4 in this example. Substituting in, we're going to get 4 is equal to -3/5 times -3 plus b. Now that b is our only unknown, we can solve for it. Rewriting this, we're going to have 4 is equal to -3/5 multiplied by -3/1 plus b. Multiplying this -3/5 by -3, we're going to get 4 is equal to +9/5 plus b. To make things a little bit easier, we could rewrite this improper fraction as a mixed number and say 4 is equal to 1 4/5 plus b. And subtracting 1 4/5 from both sides of this equation here, we can find that b is equal to 2 1/5. Finally, we have our b value, or our y-intercept. Our final equation in slope-intercept form is going to be y is equal to -3/5 x plus 2 1/5. Let's plot our original 2 points on the graph and see if this checks out. -3, 4 is located here in quadrant 2, and 7, -2 is located down here in quadrant 4. Here we can see our y-intercept of 2 1/5. That's a pretty good approximation. And for our slope of -3/5, we can see a vertical change of 3 units down to a horizontal change of 5 units to the right. And if we do that one more time here, we can see that we do end up on our other point. In example 4, let's take a look at horizontal and vertical lines. Horizontal lines will always have a slope that is equal to 0. The reason why this is because there's no vertical change. The equation of this green line to the right is just y is equal to 8. If you were to pick 2 points on this line, because there's no vertical change, you would get a slope of 0. What about this horizontal line over here? The equation of this horizontal line is just y is equal to 4. And this horizontal line over here, the equation of this line is just y is equal to -3. Every horizontal line you'll ever see will just look like y equals, and it's just going to be some number here. So what about vertical lines? The slope for vertical lines is always going to be undefined. The reason why slopes of vertical lines are undefined is because there's no horizontal change at all. We can't ever divide by 0. The equation of this vertical line is going to be x is equal to -2. The equation of this vertical line is just x is equal to 5. And finally, the equation of this vertical line to the left is x equals -8. The equations of vertical lines will always look like this: x equals some number. These two types of equations are unique because horizontal lines have no vertical change, and vertical lines have no horizontal change. That means that the slope for horizontal lines will always be 0 over some number, and the slope of vertical lines will always be some number over 0. For horizontal lines, 0 divided by any number will be 0, and for vertical lines, the slope is undefined since we can't ever divide by 0. In example 5, let's try a couple application word problems. Pause the video to read the question and try it on your own. Unpause the video when you're ready to go over it with me. First, we begin by defining our variables. X represents time, and Y represents the number of plants Maddie has. We can write this ordered pair 0, 8 because we know she already has 8 plants. At 0 weeks, she has 8 plants. Since we know that Maddie's buying 3 plants every week, this is a rate or ratio of 3 plants per 1 week. 3 per 1, or 3 to 1, just simplifies down to 3. This is our slope. Here we can see that 0, 8 is our y-intercept, while 3 is our slope. Substituting these values in, we're going to get y is equal to 3x plus 8. This represents our linear equation in slope-intercept form. So let's use this equation to find out how many plants that Maddie will have in 7.5 weeks. Since x represents time, we're going to substitute in 7.5 in for x. Substituting in, we're going to get y is equal to 3 times 7.5 plus 8. 3 times 7.5 is going to get us 22.5, and we still have a plus 8. And 22.5 plus 8 is just going to be 30.5. At this constant rate, Maddie would technically have 30.5 plants after 7.5 weeks. And let's try one last one. Pause the video to try this on your own and unpause it to check with me. First, we begin by defining our variables. X is going to represent time, or number of hours, and Y is going to represent the number of routines she did, or the number of times she practiced. We can then write these two ordered pairs of 3, 39 and 12, 111. The 3 and 12 represent the number of hours, while the 39 and 111 represent the number of times she's practiced. We can then label these points as x1, y1, and x2, y2. We can then use this information to find the slope. Here we find out that our slope is 8, which means that Kendall is practicing her routine 8 times per hour. Substituting this into our equation, we're going to get y is equal to 8x plus b. Since we have to find b, we must know what x and y are. While we could use either of the points we were given, I'm going to use 3, 39. Substituting in, we're going to get 39 is equal to 8 times 3 plus b. Since 8 times 3 is 24, we can simplify this down to 39 is equal to 24 plus b. Subtracting 24 from both sides, we find that b is going to be equal to 15. Our equation in slope-intercept form is going to be y is equal to 8x plus 15. This positive 15 represents the fact that Kendall had already completed her routine 15 times before we started counting, and this 8 represents the fact that she's practicing her routine 8 times per hour. Using this equation, we can find out how many times Kendall's completed her dance routine in 8.5 hours. Substituting in, we're going to get y is equal to 8 times 8.5 plus 15. 8 times 8.5 is going to be 68, so we're going to get y is equal to 68 plus 15. Here we're going to get that y is equal to 83. In 8.5 hours, we can predict that Kendall will have completed her dance routine 83 times. And that wraps up this video on slope-intercept form. If you found this video helpful, please let me know in the comments section below. You can also let me know by clicking that like button or maybe even subscribing. Keep up the good work, and I'll see you in the next one.